Hello, everyone. Welcome to the Construction Technology Podcast. I'm Luigi, CEO at Provision. I'm joined by my co-host Mike from Build Vision and Andrew from Join. We have a special guest today. It's Andriy from Nomic.ai. Andriy, how are you?
Hey Luigi, hey everyone. Thank you so much for having me. I'm Andriy, founder and CEO at Nomic. We build agentic systems that accelerate design and engineering and construction.
Andriy, great to have you. Obviously, we did some research prior to you joining. We know that you pivoted into AEC and are now selling, it looks like a variety of products, some being ML APIs that help what seem to be technology companies have a more programmatic understanding of construction drawings and construction documentation. You've already detailed the pivot into AEC in previous interviews, but maybe for our audience, which mostly skews towards technology, construction executives within the technology space, just give us an overview of what was attractive about the industry and what led you there specifically.
Yeah, it's a great question, and obviously we get this a lot. So a little bit around a year and a half ago, I would say, is really when we kind of fully embraced like a pivot into a verticalized AI space. And there's a lot of calculation that went into this. Nomic, we were founded a little bit under 4 years ago now. We started out as a kind of a horizontal AI infrastructure company. We built AI models for search, AI models for document understanding. Some of them are, extremely popular to this day. Millions of downloads on open source platforms. And this sort of infrastructure play, while we were getting lots of, let's say, like open source traction and lots of users using our products and software, we were finding basically it extremely hard to commercialize as a business because we took a very big like open source approach to the whole strategy of the company. Which I often talk to people about. Whenever you're building an organization, you have to not only solve several hard problems in sequence over and over again, and reach increasingly new harder problems to solve. You also have to align yourself with the right exponentials that are happening in the greater environment. For example, 4 years ago, the right exponential was not building agents. The right exponential was, frankly, helping the world figure out the places where AI was working and AI was not working. I think as of like a year and a half ago, if you're an organization that's not hyper-focused right now on building agents or helping organizations orchestrate agents, you're probably working on the wrong exponential. So about a year and change ago, we were sort of really thinking about what does it mean to build the next great generational company that unlocks this like new transformational wave of technology for a wide audience of individuals. We were thinking about things like what is the hardest data domain right now where AI systems just don't work, right? The place where there's insane product market fit right now with AI systems is places where the input is mostly textual and the output is mostly textual. Things like code. Those are the places where domains are highly verifiable. What this means is that AI systems can progress and evolve in these data domains like coding. You can now build complete software applications with a single prompt. But in places like design and engineering and in pre-construction, the kind of tasks you have to solve are highly multimodal. What this means is that you need to operate over top of images. You need to operate across vector graphics. You need to perform operations that language models are really bad at. Exhaustive counts, for example, if you're doing a takeoff. These are places where language models are not that good, just innately from how the way they operate. They're not exhaustive. And as we were considering this and also looking at sort of the greater market trends, it just became really clear to us that the direction we had to go in was to go in and solve the hardest data problems that existed out there. And it turns out the hardest data problems don't exist in the digital world, they exist in the built environment in the physical world. So we actually set off and for about 6 months kind of put our head in the dirt. We're building out custom models that kind of close the gaps between what foundation models could do and operate, and working quite closely with a sequence of design partners to really nail out what are the extremely high ROI relative to AI usage cost applications and use cases that are universal regardless of whether you're a professional service firm on the A&E side or running a traditional like GC. So a lot of what we do today, a lot of our product form factor is built around out of these learnings as we sort of kind of entered a new evolution of the company about a year and a half ago. Hyper focused on solving the most critical and important problems that slow down the design and construction of physical assets. And frankly, what we realized over the course of that 6 to 8 month kind of build out period was that it's all around project coordination. The build out, and I think kind of the impetus for this conversation was our recent launch of AEC Bench, which is kind of an open source benchmark for measuring. It's a measuring stick for AI agents on project coordination tasks. A lot of that came out from our learnings from that too.
That's a fantastic background. One interesting note about how this podcast came together, Mike and I had a disagreement on LinkedIn on whether or not LLMs could quote unquote solve estimating tasks, plug and play off the shelf. And obviously I took the position that they couldn't, and Mike was, playing along and took the position that it could. Maybe Mike has changed his perspective a little bit on this, but I do think there are inherent limitations in LLMs. And as you go into document understanding, like symbol recognition, there's only so much that these LLMs can do. And I tee this up because there are a group of people who still believe that LLMs will completely subsume, let's say, the takeoff, coordination, estimating space out of the box. An example of this may be people pointing to certain advertisements from a company called Perplexity, which is saying, we can do estimates for you. Now, to do estimates, you need to have cost data, you need to be able to do symbol recognition, you need to be able to do area understanding. These are completely different problems. As part of what we wanted to do here was kick off a process, which I'll hand over to Mike, to see how Perplexity does for a project that Mike has a ground truth for. And I think it'd be an interesting experiment as we continue to dig into your background and obviously Nomic.ai's capabilities. I'm obviously expecting this to fail, partially because I've seen the results. But would love your perspective on that divide, Andriy, and maybe even commenting on why certain people think it works versus your obviously in-depth understanding of where it fails.
So before you go into that, let's kick it off just because it takes time. So I think everyone saw this kind of floating around LinkedIn. So Perplexity is using some, I guess we consider GEO, generative engagement marketing. So it created this web portal, says turn blueprints into accurate estimates within minutes. So I'm actually going to go ahead and choose a file. I think the first thing that it actually does that's interesting, there's a limit on the file size to 50 megabytes. So I had to reduce this down pretty large. But as I go through this actual workflow here, it actually doesn't do anything. It just takes you to their chat interface. So all those steps before, it's very generative. It's very marketing led, which is understandable. They're super early in the process. So I actually went ahead and just manually did this. So I created a prompt that says you're a mechanical subcontractor preparing a bid proposal for this project. So I'm going to go ahead and launch this one. I also did the same thing for Claude. Claude just released 4.7. It's going to launch that one. And then also going to launch one in ChatGPT with Extended Pro. These will create proposal outputs with the prompt, and then I'll actually have it run through and do a bid level exercise. Just setting the background again. This is going to take time, so I'll let it run in the background, but I'll pass it back to you all as it kind of cooks.
Yeah, so I think one thing Luigi said was he doesn't believe that language models are sort of on the right trajectory to be able to solve a task that's both diverse across disciplines, right? There's hundreds of different tools and solutions out there for every single unique discipline. There's electrical takeoff software that has product market fit. There's mechanical takeoff software. And the reason you need this is because I think in the previous generation of software was constructed, very rule-based, obviously human engineered. You had to carve out all the differentiating artifacts and aspects of every single discipline to be able to do a task like a takeoff. I actually kind of disagree with you, Luigi. I think we will reach a point. It's a much harder task than a task like, let's say, marking up a drawing relative to a set of rules or a standard doc, because a takeoff it's a multi-step process that involves complex operations like calculations, like exhaustive counting, where if you mess up the end result. It involves not just it's oftentimes not sufficient to purely look at the drawings or plans, even though that's kind of the intent to go in and perform it. All of these kind of things put together make it something that if you go in and kind of go to one of the out-of-the-box agents out there, so the agent that powers ChatGPT, so it has access to web search tools, it has access to maybe a code sandbox to write some code to perform a calculation, or you go into Claude like Mike just did, you're getting basically a very nerfed version of these systems that don't do a good job at running for a long time, especially in complex domains and complex tasks. From what we've been seeing, at least, it's more of a question of how much are you willing to experiment with longer range running tasks that might burn you a couple of $100s of AI spend, right? What is the actual human labor that goes into performing a takeoff, right? Potentially, you're spending thousands of dollars of either billable time or company time to perform a takeoff task. Is it warranted to spend $200 of AI time or $300 of AI time to do this? The answer is probably yes, but you're going to be hard pressed to find a system out there that lets the average internet user accidentally burn $200 before seeing an output to really test out the capabilities of this thing.
Can we yeah, just I have a question. What do you mean you're building custom models? Like, is that the foundational models spend billions of dollars training a model from scratch? What is a custom model to you?
Yeah. So whenever you're building an agent, you're kind of layering on three things. You have the underlying foundation model. So like what is the actual driver model that is doing the tool calls, bringing information into context to go in and make a decision. So in the screen we're looking at right now, this prompt into Claude, this is running the actual driver model that's being running here is Opus 4.7. That base model, you can pick whichever foundation model provider you want. You can go with OpenAI. You can go with Gemini. You can go with GPT from OpenAI. They all can go in, call tools, bring information into context to solve a task. The next layer of information is the actual tools that the model has access to. So for example here, Claude clearly has access to the ability to write a bash script, write some code, execute some code. That's a tool that not every single language model harness, so agent, has access to. And that's going to give it differentiating capabilities to be able to solve harder tasks than a different agent can solve. And then finally, you have the environment which the agent operates in. If the agent is, for example, marking up a PDF, you want the agent to be able to produce markups that maybe are compatible with review software, like Bluebeam Review, right? So it has to operate in a sandbox environment that matches the environment that a human lives in. All these three levels are places where people who are building agents, especially agents for the built environment, have to think very carefully about tinkering and configuring and adding custom capabilities to be able to sort of close the capability gap that's native to foundation models because they haven't seen in their training distributions or their training data sets, many takeoffs, for example. I think we're talking about takeoffs here. So what we do very specifically is we work in that second layer, the tool layer. Our custom models can go in and take a drawing. I can take a spec PDF and transform that into a form by going in and performing various layers of information extraction, things like creating aggregate counts of symbols that allow for the underlying foundation model that then makes a tool call to not have to say, okay, I'm going to spend a bunch of time now trying to figure out how to accurately count all these 97 symbols across 50 sheets. It's going to have that information pre-computed with another system that's more rules-based. And then these kind of tools allow it to be a lot more accurate, a lot more consistent, and spend a lot less cost to achieve that end outcome. So our domain-specific models, they're something called parsing models. So they go in and they basically go in and can take a drawing, take every single detail, every single table, every single legend, structure it out of the document, and then provide it as a interface for agents to use to be a lot more effective. So basically, to generate a higher quality set of actions while also using less tokens, so also being cheaper. And we find on our end, especially, so 9 months ago, this was basically critical to make anything work at all because the foundation models were frankly like absolute garbage when it came to the multimodal inputs that govern any kind of project coordination tasks, especially including drawings. They're getting a lot better now. This is one of the reasons that we build benchmarks internally because we want to know when we can turn off our expensive domain-specific models and rely more on the foundation models as we deliver our offering. But hopefully that gives you a little bit of a better picture of when any company out there say they do domain-specific models in a world where you have billions of dollars of investment going into foundation models, they likely mean that they're operating and injecting custom tools or custom environments into the underlying agent that they're using to deliver that outcome and that task at a higher quality and most likely in less time with less token budget.
So just like step out and even simplify that a step further, because I think a lot of like listeners on this call are like seeing, seeing Anthropic, seeing the names OpenAI. So there's LMs, which are these large foundation models that have been pre-trained with billions of dollars to create different metrics and different knobs internally to kind of next guess tokens in a very, very as simple as possible if you're kind of next guessing tokens, right? So in your position, your perspective, you're not changing that next guess token. you're taking these foundation models and then you're almost like layering on top the ability to go plug into a Bluebeam and use Bluebeam as a tool to do X, Y, and Z. You're structuring down data and saying, hey, we're going to name this file schedule. So when you call a schedule, as opposed to the foundation model going through the thousands of pages again, it's going to know exactly to go to schedule.
Yeah.
In like a very simplistic way, right?
100%. Yeah. And it's not just us. Any agent builder
Yeah.
building something that works is doing something like this. The biggest thing that we differentiate on is that our tools that the agent is using are actually custom AI models that do a first pass before the foundation model even touches the data to allow it to have a much higher quality interaction.
So Andriy, if you go back, let's go back to the original premise of how we started this. I have a belief that, let's say, LLMs currently as they exist could not do something like a takeoff very accurately. It sounds like you disagree. I just want to understand your disagreement. Do you disagree that an LLM by itself out of the box would not be able to? Because what you're describing obviously is a harness. The harness that you've built within Nomic.ai uses different models. Maybe you're using a vision language model, or maybe using custom models or some kind of computer vision model. But doesn't that agree with my point that LLMs as is cannot out of the box do a takeoff accurately?
Okay, 100% agreed. If you're just going in and sampling from a model that you give it a bunch of text and it generates out the next like half word, 100%, it's not going to be able to do a takeoff. But I don't think a single human in this room has, I personally haven't in like 3 years, interacted with a raw LLM. You're always using something like ChatGPT or Claude, which is actually an agentic harness that's been like hyper tuned to give you happiness to use it so you come back.
Yeah, that's a fair point. So what is the Nomic.ai product? I mean, obviously we went to your page, we see your products page. It sounds like you have a few products. You have the harness, you have custom models, you have APIs. If, let's say, the CIO or CTO of a general contractor wanted to improve their quality assurance process and they said, Andriy, help us, what exactly would you be plugging into their system and how would you do it?
For sure, yeah. Our core IP at Nomic is our agentic harness that produces outputs and works with designers, engineers, pre-construction teams to deliver tasks and work output that is acceptable in quality, so it doesn't require a bunch of rework or kind of redoing the task across a broad range of project coordination tasks. So on the design and engineering side, our agent can go in and automatically review a drawing set against a standards doc. So an internal standards doc, a client standards doc, international codes and standards that our agent has access to, and not produce a table of like, here are the problems. It'll actually mark up the drawing in the exact same markup formats where you can drop it into Bluebeam and go look at it in the markup bar. That same agent harness that we build can also go in and review a submittal for you. It can also go in and integrate, if you're integrated with a project delivery software, so on the horizontal side, something like a Bentley, or on the kind of general purpose side, Autodesk Construction Cloud, pull information automatically from the APIs of your setup project in those systems, run those operations, and push that information back in with human approval. So our core product and our core capability is that we're building an agent that can perform design, engineering, and pre-construction tasks across a wide range of different tasks that happen across project stages and life cycles. So 30%, at 60%, at 90% on the design and engineering side. After IFC, when you're going in and doing like progressive takeoffs on the pre-construction side and all the coordination that follows that. But that's kind of our core IP and technology. Our actual product and platform is a platform that allows for design and engineering firms and design and engineering teams at GCs to go in and orchestrate those agents extremely effectively. So we have the agent, and our actual platform and product allows your teams to onboard, to collaborate with that agent. Give it, you can log in, give it a drawing. Within 2 minutes, you're getting markups pushed back to you on that drawing that you can export out, keep using somewhere else. And most importantly, we're deeply integrated with all of the places where your source of truths and project delivery state sits. So on the design and engineering side, all the project delivery software, ACC, Bentley, Aconex, all the way down to the contracting side, places like Fieldwire and Procore. This is really important because for a human to be able to accept an agent's output, that agent must start work in the places and in the formats that humans start work. So if it's a gigantic submittal package that comes in a zip file, guess what? Like that agent better take that zip file. And it has to end work in the same outputs and formats as the human will accept it. So if that means PDF markups, it has to generate PDF markups. It can't generate a table. If that means an Excel file with 10 sheets formatted with the right headers for every single schedule that exists in the drawing if you're performing a takeoff, it better do that. Otherwise, you're going to make the human redo work. We focus really aggressively in making sure that we meet all of those conditions, because that's what I truly believe is needed to allow for the skilled professionals in the built environment to be able to collaborate and work with agents effectively.
Fantastic.
So, Andriy, you've got a pretty strong academic background in computer science. Are you familiar with like Rich Sutton's like the bitter lesson essay?
Yes.
This was here. I'm going to share my screen and take over.
Sorry.
I think I read that the first time when I was like 16 or 17.
Yeah, great. And like you probably could have, because it's just text here, like. And so I'll just summarize it quickly, and then I'm really interested in your take on it and how it applies like to what you're doing at Nomic. But the bitter lesson of Rich Sutton is that all that matters is scaling applied compute. That there's this long history of humans taking human researchers taking some capability in a computer and saying like, oh, if I teach it about this domain, if I inject my special knowledge on top of this generalized technique, I will be able to build something that will solve the problem and will always like be the best. And you need my like specialized expertise to be embedded in the system. And like the example he gives is chess, right? Where people have been building chess engines for probably literally 70 years. And they eventually won when they abandoned like anything about chess, right, inside the code base. And it was like this very like deep search place. And then like Google did this with AlphaGo as well, right? Where there's like no code that like understands the Go rule set. Like it's all learned and it's all this like scaled compute. I know I know a few other companies in the AEC space where circa 2022 or 3 or 4, whenever it was, they were using models that they've trained themselves, like that they had built to understand code or understand contracts or understand drawings, like whatever it is. And then it became clear that ChatGPT like was better or was very quickly going to be better, and they switched over to like leverage these foundational things. And so I'd love to hear your take.
Yeah, no. So this is by the way like one of the most cited papers when it comes to like how you should go in and kind of if you're building a product or you're building some sort of technology over top of the latest wave of tech. How do you build that correctly so that you don't end up on what I said earlier, the wrong exponential, right? And what Richard Sutton is saying in this piece is essentially the only thing that you can bet on, which has been consistently true across the 60-year history of computing and leaving the research space and entering, the general population's consumption, is that everything you do needs to be hyper aligned with the idea that every couple of years, the processing power of systems, whether it's processing power on CPUs or processing power on GPUs, is going to improve. And you need to build methods that scale in quality as computing power scales. So an example of one of these methods is like deep learning, which basically allows for you to go in, give a large set of tasks, a data set. You go in and you plug in a really big model. You plug in a bunch of really big connected GPUs over top of that model. You spend a bunch of time burning a bunch of electricity, and then out comes out a model that can go in and perform the tasks that you gave it as input. And this is one of the reasons you've seen insane growth of this technology, is because it's a method for computers learning to perform actions like humans learn actions that scales really well the more compute you inject into it. The bigger data center you build, the higher quality the end model that you get. The more tasks you put into it that cover the distribution of tasks you want the model to be able to perform. So when I say distribution of tasks, a task might be do a takeoff. go in and answer an RFI accurately relative to a folder of project files, mark up a drawing relative to like a standard. Those would be examples of tasks. As you go in and produce more of those tasks for the model to train on, you can go in 1 year, just train that model, and then as computing capabilities improve, 2 years later, if you just perform that same retrain, you're going to have a higher quality system that comes back out. That's what Richard's system is saying here.
Okay, and so you're for Nomic, you're leveraging these foundational models, and so you can plug and play them. And so as new foundational models come out, like your system gets better.
Exactly.
But like I think it's the harness layer. That layer is also moving pretty quickly. Right.
Yeah. So, well, this is part of it, right? It's like the whole reason everyone's talking about this word harness right now is because I think everyone has deeply internalized the phenomenon that Richard Sutton's piece here is like trying to describe, which is, if you're going in and fighting against this idea that with the same data set 2 years later on a much larger computing regime is going to produce better AI models, you're on the wrong exponential of where this technology is going. The reason we go in and we've basically built our product all around an agentic harness is because I deeply believe in 5 years, a lot of the work that's going to be delivered is not going to be, people are not going to be purchasing rent in SaaS systems and paying some monthly rental fee for like a seat or a license to be able to work with technology. They're oftentimes going to be purchasing service as a software, the end outcome coming out of the technology. And that's all based around agents actually working on the task distributions that exist in various verticals and various industries. I think the place where people maybe take the wrong lesson sometimes from Richard's piece here is that it doesn't mean that you don't need individuals hyper-focused on specific domains. It's only a commentary around building systems that scale as computational capabilities scale, which has always been a truth the last 60 years. It's still really important to remember that these computers are here not to replace us, they're here to empower us and help us deliver the work that we're doing every day better. On the software engineering side, there's more software engineers out there since AI has came out, not less. Even though AI is able to go in and take a lot of tasks that software engineers do it end to end. People are getting a chance to do more and being able to do more in shorter periods of time. We're kind of seeing frankly the exact same thing. Some of our larger partners on the design and engineering side, they're able to go in and tackle more work because they're having agentic systems that can go in and review a submittal in 5 minutes as opposed to 8 hours. The tasks that humans hate doing are oftentimes the places where agents can do a really good job at producing first passes that humans can then spend time there. It's really important to, I think, differentiation between Richard is not saying don't build domain-specific systems. It's saying build systems that scale as compute scales. But those systems need to understand very deeply where humans start work and where humans end work for humans to find them useful and accept them into their daily work streams.
Doesn't that we even coded the workflows of AEC, you could argue poorly, into software. The trick is it's in all the systems that you mentioned. It's in the ACCs, it's in the Bluebeam, right? Like Bluebeam is where you understand and mark up drawings, right? And so if that's the front end for the workflow, I guess the most challenging version is to be like, why do I need Nomic? Like if over time, Bluebeam, they bought Forma, whatever it was.
Firmus.
Formus, yes,
Firmus,
Firmus, yes. Sorry, haven't had enough coffee. One of those F names. And work is still going to happen in Bluebeam, and the most differentiated capability remain the foundational models. Like everybody's calling into the same foundational models. Like, why do I need Nomic?
Yeah. So everyone's calling into the same foundational models, but everyone is most certainly not using the same harness around the foundational model. And as I said, our core IP is not the fact that like we were clever enough to use 4.7 2 days before somebody else. It's the fact that we've spent over a year building a agentic harness that can capture and perform a lot of the task distribution that governs a lot of the tasks that designers, engineers, pre-construction teams do across project coordination, for example. That's our core IP. And the reality is that number one, teams in existing software oftentimes aren't working on this and aren't being focused on it. The other thing is there's a lot of constraints that exist in those systems that prevent for this technology to really blossom to I think its full fruition in those.
This is what you mentioned earlier about the just sheer amount of electricity that's necessary to use to execute these tasks.
No. I mean, like, just like the guardrails in place when you're working with a software that's 30 years old that kind of hinders innovation to happen at these organizations, right? Like we go in and you can kick off, for example, one of our Nomic agents via an API. In Bluebeam, if you wanted to go in and in a comment markup, kick off an agent that would go in and generate more markups, you could do that via our agent API. And the reason you might care about this is because it's very hard to replicate the kinds of capabilities that we've built into our harness because it requires a lot of iteration and frankly a lot of data work to be able to do well. Like one of the biggest things I would say like is our competitive advantage at Nomic is that we take benchmarking to heart. Like when we released that AEC benchmark, which is basically like 200 tasks that we have seen in real world sort of like world environments that people have to perform every single day across drawings, across project documents, across specs, and really codify that into like a labeled data set that we work with our agents to be able to replicate so that when these agents are actually deployed into production, humans are finding them valuable. We have a much larger internal data set in the company that we haven't released. That's not part of our open source release. And the reason for this is because if you want to go in and you want to iterate on building a better agent, you need to make sure you're not regressing in the capabilities that you delivered last time. It's kind of like a measuring stick, like a test every time you go in and release your software. And our biggest differentiator, the reason we're able to ship so fast, and the reason we're able to maintain such a high quality, is that we spend a lot of our resources. Like I have structural engineers on staff, literally going in and hand doing takeoffs right now, purely for our agents to be able to measure themselves and their takeoff abilities. And that's a really big differentiator too.
I think part of the tension that Andrew's getting to is in Rich Sutton's piece, you could take away that the only thing that matters is scaling compute, and what the LLM providers are doing really well is scaling compute. Should we just work with them? But it's not mutually exclusive to Andrey's point, which is, yes, compute matters. They benefit from that compute, but the harness is very important. There's been a lot of research that's come out. It's very anecdotal, but LangChain, for example, LangSmith has shown that changes to harness can materially impact performance across various benchmarks, let's say on SWE-bench, the software engineering bench. So harnesses are very important. And for people who are listening who don't know what a harness is, it's effectively a chain of prompts and tools and context that you give the underlying LLM. Let's say an LLM has this context, which is all of the spec information that's extracted or structured, let's say in JSON. It now knows it can call a tool, read spec, versus let's just do a regex for various terms. It makes it easier for it to hit certain results. And so Andrey's saying with their harness and with additional tools, he can benefit from the scaling compute and disproportionately provide value to customers compared to OpenAI. Obviously, Turner, for example, spent a lot of money with OpenAI. I think people who are construction executives are thinking like, well, should I go domain specific or should I just go with OpenAI? OpenAI is going to give me the best bang for my buck. They're going to scale compute faster. I actually don't need Nomic, or I don't need join, or I don't need provision. It really depends. And like, I obviously believe that if you give agents certain capabilities, it's going to be better, materially better than just an out of the box, let's not say undifferentiated, but unspecialized. It doesn't have access to special tools or context. As they compare to Nomic. And then obviously what Andrey's saying is where these people do the work is very important, which is why you're not just saying, Andrey, we just do custom models. You're also saying, no, I want you to work in Bluebeam, because you obviously know that the difference isn't just capabilities, it's also where your customers are doing the work.
Yeah, I mean, it's not just that's the difference. That's like 80% of what it takes to actually get humans to collaborate and accept the outputs of agents. Like 20% of the difficulty of what we've done at Nomic is build this system that can like mark up a drawing and it's producing accurate markups relative to like the specs or relative to like a standards doc that somebody has for like our drawing review capabilities. 80% of it is the change management that we have to do at every organization that we work in to train people up, to have them understand how to use these systems. We're operating and we're delivering software and capabilities to an industry that doesn't ship software to their end clients. They ship really complicated, highly risky physical assets that require years to build and construct, and it's a very human-centric industry and a human-centric space. There's absolutely no reason why anyone should be trusting these systems out of the box and trusting the fact that these things will work. A lot of the time that we spend, and I would say 80% of the challenge and growth circle that we have as an organization that we're figuring out and how to sort of make work, is that change management that organizations are going through as this new generational wave of software happens.
Yeah, can we go back? Can you pop open the blog post for the benchmark set? There's a graphic there I want to ask a question about, but maybe while that's happening, I'll just sing the praises of like more power to you for like putting the effort in and then publicly releasing like something quantitative about performance of these systems in the AEC domain. I think that's like commendable and sorely needed. If we zoom, can we just zoom into that top graphic? Basically, to the right is good, and green is Nomic, and then it's better than OpenAI, and it's better than Anthropic, right?
It's better than a specific, very popular general purpose harness that OpenAI has around their models.
Okay, so it's better than the Codex harness, and it's better
Yes.
than Claude.
Claude Code harness, yeah.
The Claude Code harness. Oh, that's interesting.
Because Andrew, just as a pause on that to clarify, right? Because like for everyone listening, right, Andriy could be could be using the same LLM as the foundation, but his harness on top of that is doing these unique tool callings that is increasing the efficiency. So if you just like blanket hit just the LLM on, the very, very basic one, it might be 50%. And then using Anthropic's Claude Code, it goes from 50 to 57. Uses OpenAI plus Codex goes from 60 to 62. So just like very much simplify that. Like there's still like this one point that's 50% if you just like one shotted it to a very like LLM, and then there's these agent harnesses that are increasing that efficiency and tool calling.
Yeah, the couple of caveats as well for people looking at like obviously when you go in and you behind this release, we have a paper, we have a code base, we have a big data set of like literally hundreds of drawings with like markups of engineers over top of it, submittal reviews that happened over top of it. But like what you're looking at is a very abstracted out sort of like set of bar charts that partially, our marketing team had to go in and have some opinions on. So like this is why like things are very simplified here. But I want to peel back a few observations. So like in what we do here, we actually explicitly say that like the main agent that's driving that LLM that's actually driving the capabilities in this case in all these benchmarks that we ran is actually I think it's Claude 4.6 with our set of harness and tools. And the whole point of this benchmark in this release from like the Nomic side, apart from releasing the data set, is what we were trying to convey is that the most important thing about building an agent that can operate in the built environment is not the underlying LLM. It's the harness. It's the set of tools in the environment that it operates in that gives it that set of capabilities and that extra boost in performance that oftentimes is a step function boost in a human being able to accept and work with its outputs. Because oftentimes what you'll get is, you can go in and let's say stick a drawing into ChatGPT, it'll happily go in and give you a table of markups. Guess what? The false positive rate's going to be so high it would have been faster if you did it yourself. That's the kind of step function change I'm talking about. And these numbers, these scores, these reward scores might seem like they're very small, but even a couple points boost is oftentimes the difference between a human accepting the output and actually finding it accelerating them versus it being slop that they have to go in and rework anyways. So that Claude code, that Anthropic Claude line that you see, another objection that I've kind of heard in the past and had to explain before is, Andriy, you're evaluating an agent that's supposed to go in and do design, engineering, and pre-construction work against an agent that's supposed to be writing code? That makes no sense. So it's called Claude Code, right? It's called Codex. One of the things that has been observed and across verticals and across domains is that these agent harnesses are not just harnesses for writing code. They're harnesses that are actually general purpose agents that can go in and solve many tasks across many domains. Code is just the medium through which they're able to go in and store memory, store operations to be able to solve those longer running tasks. This is why it's a very fair comparison to be able to take the latest version of Claude Code, that's a big harness, obviously powered by Claude as the LLM, the latest version of Codex, a big complicated harness, obviously powered by GPT, and compare them against our custom harness, which is obviously specialized for design, engineering, construction tasks.
Okay, and so great. So this is really benchmarking the harness. If I'm understanding that right.
Exactly. Anytime you're benchmarking agents, you're only benchmarking the harness usually, which includes the
now.
LLM.
So you've been doing this for a while. Does the Claude as new models come out from Anthropic? Does the Claude bar move to the right?
The Claude bar is going to move to the right every single time there's a new LLM release, every time somebody ships a new change to the Claude code harness. That's good. There's going to be a change. So this is obviously like a benchmark at a point in time. That's the problem with benchmarks, is that to say something and be able to analyze it, you have to like snapshot a point in time. But the whole point here, and the whole point of any company that's building an agent in this space, is that as those foundation models ship improvements, ideally they're building their harness in such a way where they can instantly capitalize on those improvements themselves too.
So the the statement is like the new model comes out, Claude moves from 57 to 75. At the same time, Nomic would move from 70 to 90 or something. Like Nomic will always, because it has a domain-specific harness, it will always exceed these horizontal harnesses.
Yep, and that's the claim that we like really tried to. We're in these things called ablations, which means like we take away things from the harness and see how that impacts performance. It's like very well explained in the actual paper that accompanies this blog post, and you can literally see as you take away tools, quality starts degrading in the actual end agent until oftentimes you are much worse than the harnesses that power Claude Code or Codex. But the same thing with the Claude Code and Codex harnesses. One of the biggest things we identified, and I'm scroll down here for a second, is that one of the reasons they in many subtasks. So like we broke down the benchmark to cover tasks, project coordination tasks that you can do in a single sheet, project coordination tasks that require context across a whole drawing. So you might have to navigate across sheets and across disciplines, coordinate across disciplines, for example, and then project coordination tasks that require navigating an entire directory of, let's say, project data. So a file of specs, a project manual, a drawing, and maybe various revisions of that drawing. And then maybe you also have, let's say, like a textual RFI come in, or like a zip file containing a product submittal that comes in, and having the agent solve tasks at that level of granularity too. And this is all to say is that as you peel away tools and capabilities, you can really see a kind of monotonic shift in the model's ability to perform sets of tasks that exist in each one of these kind of task categories.
It's funny, the thing that's jumping to mind for me is weather prediction, where like it's another domain where we figured out how to scale compute. Like it was by simulating weather patterns at greater and greater granularities. And there are these awesome curves. I tried to pull it up, but I couldn't find it, of just like the improvement in accuracy over time, or reduction in error over time of the compute models. And the way that they were used was like in a given year, the human plus computer, was at a certain point, and a few years later, the human interpretation wasn't necessary to achieve that level of accuracy anymore. Like the just computer on its own had gotten better and had exceeded the previous sort of like domain specific like application of it. But the humans still provide an edge on top of that like, domain specific interpretation and understanding and massaging of the like computed outcome, like continues to provide an edge. And so you fast forward, the computer is better than the entire like domain specific plus generalized tool was. But like if you layer that specificity on, like you're writing a better curve over time. Okay, thanks. I think I get it. Obviously not. Yeah.
As we like take a step out of this, like, so I know I always talk about Harvey and Legora, similar to the customers you sell into the AE space, like they bill by the hour. So from their perspective and like your pitch to them from a business model perspective, how is that resonating with them? Is it like, because like, hey, I bill 1,000 hours for this project, and now you're telling me I can theoretically do it in 100 hours? Yeah. Does that change their what does that look like for you? I know like one thing that I always try to tie to is like, what's the actual outcome? Yeah. I would love you to unpack that, because that's what people want to hear here is like, what's the, hey, it's great that this works, but now what?
Exactly, right. But what is it like? Assume like this is not like marketing. It's not vaporware. These things actually work. What does this mean for the reality of like how humans operate and how these industries operate? And I think the analogy you make with like legal organizations is very apt. A&E, architecture and engineering. These are oftentimes consultancies, professional services businesses whose traditional business models revolve around making a margin across billable hours that then they resell to the teams that they're teaming on physical asset design, engineering, and construction, and also performing things like consulting on like repairs and inspections to municipalities. And sort of the question Mike is getting to here is, what does it mean when you inject a piece of software that makes one of those humans more efficient at their job, or even for many tasks, turns a job that would have taken 8 hours into a job that would have taken 5 minutes with 10 minutes of human verification and checking time? What does that mean for the entire business model here? Does the business model collapse? This is actually, and I get this question a lot, and I always remind people that like software existed before 2022 that made people more efficient. People had to consider this question way before AI existed as well. It's obviously more amplified now. What does it mean to create automations in a consultancy so that you deliver your work output with less cost of goods, but still retain that same margin? It means that people have to shift their business models to milestone based pricing, where like at the 30% mark, you get a milestone, a lump sum payment that is not tied to keeping a record sheet of hours. The problem with this is that like the timeline at which software develops and moves is much faster than the timeline, like the 10-year timeline to sign a contract around designing a physical asset and delivering a physical asset. And especially for instance with the U.S. government, a lot of the ways they only do contracts right now because the assets that they're working with are so large and have such large timescales. You're contractually obligated to go the hourly direction for how you structure those contracts. It's a very big reckoning that's happening in the space. Every company is dealing with it. I have this conversation literally every single day, so that's why I'm glad you asked about it. But the end outcome is you need to be billing for the outcome, not billing for the hours that it takes you to get to the outcome, because it makes you like grossly unaligned with what's happening on the ground in terms of delivering the end output. When your clients will deeply understand that your cost basis for that outcome is changing, people will just trust you less.
Is anyone doing it though? Is like anyone like are owners receptive to an A&E firm saying, hey, we're going to charge $10,000 to do X, and what does that go up to? Because there's obviously iterations and there's changes to drawings, and the owner wakes up one morning and says, I want a pink wall instead of a blue wall. Yeah, curious to unpack that.
Yeah, 100% is happening. It's been happening forever in, let's say, like the inspection world, right? So like A&E don't just work on brand new artifacts and brand new constructions. Inspections have almost always been like per outcome-based delivery. So that in these subsets of the business is where you're oftentimes seeing technology and innovation grow most rapidly, because there's the most incentive to basically automate work, because it's like pure margin that you're making. And a lot of new assets that are being delivered. The firms are going in and from the ground up structuring the contracts, because they're able to explain to their clients that this is actually the incentive structure that most aligns them. At the end of the day, the end cost can oftentimes be the same, or maybe a little bit less for the end client. The margin or the amount of profit being made by the firm can be kept relatively constant. But the important part is that the business model aligns with the actual realities of how that work is being executed and done.
So yeah, just a pushback on the inspection. The inspection comment, there's a 1-0 outcome, right? Like, hey, it's passes inspection or not, and then here's the remediation. One thing I've heard from specifically, I deal with like a lot of like mechanical design engineers, and with mechanical design engineers, it's like they've tried to charge like, hey, I want to charge 30 cents a square foot for my design services, but it always goes back to, hey, there's a mechanical engineer on site, there's a structural engineer on site, there's a acoustics engineer on site, there's this architect that's overarching all of this, and it's very, very challenging for them to have a cost-based lump sum price when everyone else around them has a billable hour. And this kind of relates downstream even to like RFIs and submittal reviews, where like an owner might have only paid for one submittal review for one product line, and if there's more, they're actually going to charge more, and there's always like misaligned incentives. So I'm curious, like in that ideal state for you all, is it like, could you sell Nomic to an owner and be like, hey, all these firms have to use Nomic, because of X, Y, and Z, and then also change the business model for those AE firms. And I was trying to like that's one thing we're just like we're trying to reconcile is like, hey, like this is great if I can automatically do an automatic takeoff on a PDF, which the whole underlying issue of that is like someone's already done a takeoff in a model in a BIM model or whatever, and then they have to like abstract it and do it out. But like what is that pitch and what is that conversation like, and how are you seeing value drive to that?
Yeah, so we're already working with owners and operators. We work across the A, the E, the C, and the O. Our heavy focus and heavy market penetration right now is on the AE side because of obviously where we find that's where a lot of the project coordination issues stem up, and that's where a lot of the value sits. But GCs with vertically integrated design teams or operators that are having to deal with the mess of owning the asset afterwards can get a lot of value from this tech too. I don't have the answer to the question of how do you, in every single design discipline and in every single case, make this transition happen. It's an extremely hard problem. Like this is one of the oldest industries in the entire in the entire history of humanity that has always charged in some sense per hour, right? And it is now only in the past 40, 50 years that cost basis has been significantly challenged, frankly, by technology in a major way, or maybe in the last 120 years, right? And then I think the entire sector has been coming to grasp in various different ways. In some places, it's easier. And in some places, like you were just mentioning, right, especially when you have a lot of people on the ground in person, it's a lot harder. But there are definitely subsets of businesses. Like the very concrete answer I can give you is it's a very mixed bag where there are firms that will continue having to bill by hour for subsets of work probably forever because that's just how it works. And subsets of their business can be gone in and moved to milestone-based outcomes and lump sum-based payments.
Andriy, do you have a hard stop at the end of the hour?
I can go for like an extra 5 minutes, but I do have a 10 o'clock call.
Because I know we still want to show the output from Perplexity.
It is
at
live
all.
finally.
Okay, great.
It only took 40 minutes to do the OpenAI one.
Okay, you have it ready to go, Mike?
Yeah, I'll share it.
Okay,
quick,
great.
Yeah. So yeah, the whole rep, and we'll share this after as part of the link, and so we can dive into it. But overall, like it was the same project.
Can you zoom in?
No, yeah, I'm just kidding. Just being a smart ass. Same project, same documents, same prompts across the 3 different models. Again, these are going back to Andrey's point, like these are the foundation models, the LLMs, plus the harness toolings that they have in their chat interface. So yeah, obviously you can see there's a 50% spread on pricing. Perplexity was the quickest. Perplexity is in 3 minutes and missed a lot of things. It also missed what we can go into. OpenAI came at the highest, Claude came at the lowest. Now it's all screwed up. And if you actually normalize pricing, it actually gives a recommendation at the end, which is this Flatbush company, Flatbush was OpenAI.
Where's the ground truth, Mike? Do you have this against the ground truth?
I do not right now. This was a random project that I found. But the cost is in range. The 350 is a good cost per square foot for this type of project. There was just big misses. Like one of the agents, one of the subcontractors included the owner furnished water source heat pumps, which was like a $60,000 delta. So it's interesting. Again, it does pull up gaps in the analysis. We'll share this with the team, with the link after so everyone can review it in more detail. But I think the biggest blaring kind of open piece is one, Perplexity was in the middle, but there was $200,000 spread between the lowest and highest bid on the same set of documents. And I don't know any general contractor that's buying projects on a 50% spread. This is a very small project, so you can imagine as this grows, those ranges get even larger. And just to reiterate the point that leveraging foundational models and their foundation harnesses is not the best practice, and you really have to control the conversation, control the harness that you're building to get as close as possible to what you're looking for. But it's an interesting data point for sure.
Yeah, this is really cool.
Andriy, when you show people the output from Nomic, can you give us an anecdote of what the impact looks like? Maybe not in the abstract, but as concrete as possible.
Yeah. So some customer quotes I think that get people most excited when they hear them reiterated. What are the tasks that people just really hate doing? The tasks that don't give people dopamine throughout their day. They're oftentimes the same tasks that happen across when you're doing lots of coordination work or when rework is having to be happened in those communications. So, for instance, on submittal reviews, we've taken 4 to 5 hour submittal packages that would have taken an engineer mountains of time that they would have to be deallocating from another project, and been able to do them in 5 minutes, 10 minutes, with then about another 10 minutes of human verification time. That is a insane, not only time savings, but frankly, a mental load savings. You didn't go to school for 10 years to become an engineer, to spend all your day reviewing submittals. That's an example. Another big example is on just frankly getting to the work that you can't get to on the fixed amount of hours you have allocated to that project, or the fixed amount of time you have allocated to the project. One of the really big advantages of AI is the fact that these systems can be a lot more exhaustive than humans when operating over top of 5,000-page project manuals, interspersed with a 300-page drawing set, for example. And that's another place where I think a lot of the aha moments and value comes from, is that when these systems catch things that you as a human just frankly don't have the bandwidth in the amount of times you've dedicated to the project to be able to execute on. It's cool when the agent goes in and does a markup, like it's a kind of a sexy thing when you see the agent marking up a PDF or something like that. That's not a typical output that you see from an AI system, but that's where the real ROI comes from. You're able to deliver a higher quality output when you have an agent working alongside a designer or engineer or a pre-construction team member than you would the team member working by themselves, oftentimes in a faster amount of time, which has implications to the business model and the underlying business.
What are you most optimistic about in terms of the problems that you hope to solve with Nomic?
I think one of the things I'm really excited for is the shift that's going to be happening in the next couple of years across every single industry, where as these systems improve in quality and improve in consistency, and the general public starts trusting them. Obviously, there's a lot of trust being built in daily workflows. Everyone's using some agent to go in and run research tasks, figure out what restaurant they want to go to. As it starts getting more embedded in professional lives, I think you're going to start seeing the business models of the companies that are operating shift to being more outcome-based billing, as opposed to you're buying a subscription of a bunch of seats into a product. You're going to expect that a company can go in and you're going to be able to pay $200 for a drawing review and get that drawing review out. As opposed to paying, some amount of licensing fee to go in and have access to a product that can deliver drawing reviews for $200 of AI spend, because of the pressures that are just going to happen in the market. Like, we're already seeing this in the legal space, kind of the professional service industry that I think is most similar to how AE firms operate from the business model perspective. You have companies coming in like Crosby, which are competitors to Harvey and Legora, which are, they're not selling you a platform. They will literally sell you a contract review for $100, and you pay $100 for that contract review. This is just the reality, I think, where overall software is headed. People are going to expect that software to be built by outcome. So I'm really excited personally to sort of figure out that transition as we have to meet the reality of that changing landscape too.
Yeah, so true. I think it was tried maybe poorly. I see some iterations of this. I think there was an A16Z funded company. I think they were called Palazzo that tried to do AI enabled services, but I think realized how challenging the base documents were. But it doesn't mean that it's not going to happen. It's just that was also 3 years ago. Okay, I think we should wrap here. Andriy, we're very grateful for you joining. Thank you so much for opening up and telling us all about Nomic. I'm sure our listeners are very excited to double click and see what you're up to. Really appreciate you spending the time with us, and Mike and Andrew. Fun as always. So thanks, everyone. Make sure to rate us on Spotify and subscribe to our newsletter. Thanks, everyone.
Thank you, everyone.